thanks for coming out this early morning for my talk. Really appreciate it. And I'm really happy that we are doing this. And thanks for all the organizers for a lovely conference. I'm having a very nice uh, time here in Vietnam. This is my first time as well. Yeah. So before we get started, I would like to know how many of you write code. Um, oh, nice. Most of the one. And how many of you think about writing secure code or uh, there we go. There we go. Everyone wants to write secure code, right? And nobody wants to get hacked, right? So this is all the talk is about. We're going to be talking about web security, specifically front-end specific attacks, web vulnerabilities, and how to actually protect your website or web application from these type of attacks. Uh, Before we get started, a little introduction about me. My name is Dheeraj, and I have been working with GitLab for last 4 years. I'm in the part of secure team as a front-end engineer, and we build security products within GitLab, which are being integrated to a GitLab product. And I also like to play ping pong, and I can play with both of my hands and switching in between. I like that. That's fun. And I also like to poke around the web applications I use on everyday basis for swags, stickers, and who doesn't like free stuff, right? Uh, and then this little pop-up at the bottom makes me really happy. Does anyone know what it is about? Has anyone seen this little pop-up? It's like mere JavaScript alert, and we're going to be talking more about it. But these are the companies where I have been sending a lot of reports, security bugs, and to get some free swag, like I mentioned, and just to make the web more secure. Anybody can do it. Every company has their own security guidelines, how to report bugs, and you could always go to their website and check out their security bug bounty programs or any contribution website where you can build and help them write better software and help them secure their website or applications. And so this agenda is very simple. We're going to be talking about XSX, cross-site scripting, and content security policy, and some of the initiatives we have taken at GitLab to make sure our application is free from these security bugs. And then if you have any questions, I can take them after this talk, or I'll be around the entire day. So don't hesitate to reach out to me. So yeah, first and foremost, security is important. Like it's like an elephant in the room when everyone agrees that's important, but only a few take it very seriously. So it's like some of the companies think that they are doing so good, but they don't know they have been hacked. Or there's a famous quote where some of the companies don't know if they have been hacked or they are yet to be hacked. And then it's like speeding on a highway. You get incredibly fast, and then you get fined, and then you start driving slow. So is about once your app is compromised, you lose your users, you lose the trust in your applications and the users, and so that's why it's very important to make sure these things are being thought before building the application or while building the application, not afterward. And one of the misconceptions I've seen among us, the developers and the company stakeholders, that security is only on the back end. But I'm going to talk about security stuff related to front end as well is important. And little story time. So this particular instance where there was an issue with McDonald's website. Everybody knows what is McDonald's, and we always eat it from there. But they also have a website where user can place an order online, and for that you have to create an account. And what the particular person did was there was a vulnerability using the AngularJS bypass, where the AngularJS sandbox bypass, where whatever the password you set on the website, it will be stored on the browser itself. And if you visit a malicious website, they will be able to fetch that password and send it to them for malicious intent, right? So this particular instance had multiple issues identified, and then put them all together to achieve this. So also there have been a lot many instances with WordPress. Everyone might have heard about WordPress. It's a popular blogging platform, and people build websites out of it. And so it has very much being used and abused because of they have features like extensions. Anybody can write an extension for WordPress and publish them. And there have been a lot of instances like people write malicious extension and publish it, and then it gets through, and when you install an extension, it tries to act as a keylogger and just fetch all your users' passwords, credentials, and take them to the malicious websites or with attackers. Anybody knows what this particular application is? You might have seen it, ChatGPT. There was a particular similar bug in ChatGPT as well, when somebody reported on Twitter, and they were able to fix it in no time because its popularity, where somebody just write a JavaScript code and it gets executed on ChatGPT answer. So we have been talking about this, but let's talk what reality is. What is XSX? It's called cross-site scripting. Its basic funda is when your data becomes code. In this particular example, you can see that there's an image tag with a source which is invalid, like X doesn't exist, right? And if it doesn't exist, then it will try to load an on-error attribute. The on-error attribute now has a prompt function, and which will just prompt one, and prompt one will make sure that it just prompt alert like this. This particular alert is from a website called Uber. It's very similar to what we use at Grab. So that's one of the issue I reported to Uber when I changed my name to this little code. And when an Uber admin tries to delete the user, they get this small alert. So it's more than an alert or pop-up or a prompt. It just can attack users. It can steal or hijack your or web session. It can actually record your movements or record your interaction with the website, or it can fetch all the data you try to enter on the website or the application. There are a few types of XSX categorically. One is reflected XSX, which works like an attacker sends you a malicious link, or like who doesn't like free stuff, or hey, click on this link to get free pictures of cats, dogs, or free promotions like that. And when the user clicks that link, and it executes certain code on the website, and the browser sends the private data, like we saw in the case of McDonald's. Like the McDonald's used to store the data on the website, and those data will be sent to the attacker. And here's another type of XSX, DOM XSX, where this particular code, can somebody point out what's wrong with this code and what specifically, which part of the code is actually causing the bad thing here? Yeah, that's right. So it's like a part of that. You put a query name, and with the name you try to check out the document.url. You take the URL as is, and then when you write it, the most bad code here is documented write without actually doing any validations, and just getting the query parameter from the URL and just putting in the DOM, which may lead to an XSX. So our entire aim here is to make sure that we don't lead these type of bugs into any of the applications we build or use. So if you are a coder, then you can try to analyze places where DOM elements are created, and avoid functions like inner HTML or similar functions in all the front-end frameworks. I'm going to talk about that in later slides. And one of the way is add a linter rule, like ESLint, to make sure these functions are not being used by you or any other developer using the project. And there's a famous saying like, sanitize your input, encode your output, which will solve the issue for you. But it's hard, not that simple. So are we going to be taking that look step by step? There's something called flag called secured and HTTP only flag, where you can make sure the session cookies you have. Session cookies might have some sensitive information, which is like very identical to the particular web session. So the secure flag will make sure these cookies are not being sent on HTTP instance, and they're always being sent on HTTPS. And the HTTP only makes sure that these cookies are never being read with the JavaScript code. So when somebody tries to write malicious code and they try to read those session cookies, because that's what can be used for session hijacking. So these two flags are must for any session cookies or private sensitive cookies you might have in your application. A little demo. I'll be using this. I've taken some instances from the demo to make it feasible with this. This is a secure website. Trust me, it's very secure, where you can just try to search something. And you can see that when you type in hello FOSSASIA, and it gets rendered here, FOSSASIA. And you can also check that there's a query param being entered here. Okay, so this is very straightforward. This looks secure. But how about we try something other than that? What about HTML tags? Now we entered an underline tag, and you can see that it's being sent in the query param, and it's also being rendered here with an underline. That's not intentional, right? That should not happen, right? It should have just shown you exactly what you typed in. And it's not an HTML preview website, it's a search website, like a Google search. What if we try what we have been talking about, this specific code where you write an image tag with invalid image and an on-error attribute, which leads to a prompt. And the prompt now will have a document.domain, which basically fetch the current domain value, the current URL value. And if you try to search it now, there you go. There's a little pop-up being here. Now, if you check that there's nothing being displayed here, and that's because the code has been executed and not being properly sanitized or rendered. What if we try something else? Like, what if we try to read the local storage, which might have some sort of secrets or the user credentials or some of the details of the users? And there you go. In this, it was able to read some of the secret we have stored in the local storage. And so the applications what I have been using here to show the demo, it was using a React framework. And in this React framework, this particular code, function called dangerously set inner HTML, which is by the name says it's dangerously being used with the query we use here was the user input, and it is as dangerous as it sounds. So a way to avoid this is not to use it. Only use it when you require it. In this particular case, we were rendering a user input. We just had to render it as is, and we did not actually need to use it. So we can fix it by just using interpolations. And so a rule of thumb with this type of thing is that never trust user input. Whatever a user is trying to input or enter in your application, do not trust it as is. And you can avoid things like dangerously set in an HTML for React, VHTML for Vue.js, and try to sanitize user input and escape the output so that it's not rendered as is. And build secure links, write ESLint to make sure these things, dangerous functions are not being improperly used in your code. The next topic we are going to cover is called content security policy, and you might have seen this this error in the console sometime when you visit like a Facebook.com, Google.com, or any other website, big websites who have implemented content security policy, where it's an advanced mechanism to prevent cross-site scripting attacks and other things like it can be used to securely submit forms. It can be used to migrate your website from using HTTP to HTTPS. And it also helps with mitigating attacks like clickjackings. The CSP can be deployed via multiple ways, and the most efficient way is to add an header in the code where it has setting a policy where you can set multiple directives like a default source, a script source, an object source. So for example, the script source says that only allow certain things from example.com, and the self means the same website, same application domain, and it should not be cross-origin. To understand it more better, let's use a diagram where we have set a content security policy with default source as HTTP at www.example.com, and that means that we will only allow certain resources to be loaded on the website with this particular URL. For example, if we have a request fetching file.js from example.com, it will be allowed. And similarly, if we have something called file.css, which is another file being fetched from the same domain, which will be allowed. But if the same application tries to use something from malicious.com, that request will be blocked, and you will see an error in the console. So yeah, please feel to explore CSP and have it implemented in your application. And other than that, we have HTTP security headers, which can be useful for various other type of attacks. So you can try to be as specific as possible with them. Now, the most interesting part of the talk is how we have been securing GitLab's front-end in general, and how what we have done to achieve and improve our security posture. So how it all started with a little issue few years back where we try to document and say everything on the issue that, hey, there's a lot of scope to improve our security posture. And then we analyzed all the libraries and the current code format we have to increase that and make sure that our application is not vulnerable to these type of attacks. So we have seen that VHTML is bad. Now we needed an alternative to that so that we can use it, and developers don't have to think about writing secure code. It should be secure by default. So we'll build something called vsafe HTML, where no matter what you write and send it to vsafe HTML, it will try to be as secure as possible. And it will, for this example, VHTML, if you try to enter hello with some script tags and world, and the way the vsafe HTML will try to just sanitize it, and it will just remove the bad code from it. And there's a little link over here, and this open source, so anybody can try to use it if they have it. The same Vue.js application. And then similar to that, we also built a secure link component. So where it's a GL link component we try to make sure that the links are secure by default. So for example, if somebody tries to write an href with a JavaScript code in it, we try to sanitize and just remove any malicious link with that. And so in this example, if then a GL link is having an href with JavaScript code, the output will always be an about blank or something like a null. And this is again, it's part of our component online. And then we also came across multiple problems with third-party libraries. We use particularly we use a charting library in GitLab called Mermaid, and we encountered a lot of security issues in that third-party library, and we ended up paying a lot of money to our HackerOne bug bounty researchers. GitLab pays really good bounty amount, and people try to do full-time bug bounty thing for us as well. So, but it has caused a number of XSX, this particular library, and we tried a different approach to solve that, and where we try to put the entire library output and the rendering part within an iframe, and there's something called attribute called sandbox, where you can try to contain that particular sandbox and create a real sandbox environment. And with that, we were able to contain that number of XSXs or number of issues in a third-party library without affecting GitLab.com or GitLab instances. So we tried to apply multiple defenses in our code base, and with time we have been there was a time where the issue got increased with the number of hackers trying to find vulnerabilities in our platform, and these multiple defenses applied to our code base and application, we were able to actually make the issue count drop significantly. And I think so in hindsight, it has worked out well for us. So it's good to make sure that your components you build in your company or your software application, they are following a secure by default approach, so that nobody has to think it explicitly about security or writing secure code. Yeah, what all things you can do to improve thing in your repository or a project is shift left. Try to introduce security early in your development process, and integrate as a part of your software developer lifecycle. Adopt secure by design principles, and use security middleware. Don't try to reinvent the wheel, like building your own library to for security. There's so many experts out there who has already done that, so try to use that. And similar others use standard sanitizers or the applications out there. If you want to learn about security, there's a very interesting course which I've encountered, is a Stanford CS 253 web security course. I particularly like it. And then we have OWASP development developer guidelines. Very, very nice community. They try to be up on this game. They are really helping out with everyone writing secure code. And then we have HackerOne program, Hacker 101, which is a nice resource to learn about it. And you can play CTFs, capture the flags. They're a very interesting way to learn it by hands-on sessions. And also we have GitLab's secure coding guidelines. You can just search about this, and then we try to document what we do and what we follow in terms of writing secure code. Yeah, that's pretty much. And if you have any questions, I'll be around. Uh, Thank you so much.